Hatching. In this lesson, we will get acquainted with the types and kinds of hatching, and also learn to adjust the parameters of dialog windows for hatches. We will also briefly discuss custom hatching. You can launch the dialog box using the Annotate tab, Group Hatch, or in the Home tab, Group Draw. Add hatch. The next dialog box contains a type and a hatch sample and additional parameters. We have three types of hatches. These are predefined, user-defined, and custom. You can select the hatch pattern from the drop-down list. Or we can open the next dialog box, where it will be visible what the hatch looks like. Next, we can assign a color. See the hatch swatch. Adjust the angle and scale. The angle, in turn, provides a list to select the hatch angle relative to the x-axis of the current coordinate system. Besides the list, we can also input data using the keyboard. Next, the scale, which allows adjusting the degree of compression or stretching of the standard hatch pattern. Then the hatch origin, which is used for some patterns of hatching. For example, as shown in the preview, the brickwork that needs to be aligned relative to a certain point on the hatch contour. We can use the current origin or specified origin point on the object. Then, the boundaries, using these contours on the screen, objects that need to be hatched. This command temporarily closes the dialog box, and after selecting the contour, we can continue setting parameters. The Pre-Calculate Contour search activates the mechanism of preliminary search of a contour, which will be highlighted by the mouse cursor when adding selection points. Next is the associative parameter. Associativity depends on the contour that was hatched. And, accordingly, when the contour changes, the hatching will adjust to these contours. Thus, if we turn off this parameter and when the contour of any object changes, the hatch remains unchanged. The next parameter is create separate hatches when selecting points. We hatch all objects, and subsequently, the entire hatch will be a single object. In order for the hatch to not be a whole after selecting each object, you can check this parameter. Next of importance is islands. On the preview, it's clear how the hatching will shown. But we will work with these islands later on. And if we don't need this tool in the future, we can disable it. Next, boundary retention. This mode allows saving temporary hatch contours in the document. Next is the boundary set. Now we see the current viewport, in which there is a set, consisting of all objects within the boundaries of the current viewport. But if we create a set of contours, we'll see that our parameter has changed. And a new set appeared which consists of the one selected on the screen after pressing the new button. Next is the gap tolerance. If you're unsure that your contour is closed, you can safeguard yourself and draw a preliminary contour for tolerance to closure, so after specifying this value the contour will be considered closed, and the gaps, accordingly, will be ignored by the command. Now let's try to hatch a certain area. We'll use the predefined type. For the pattern, let's select a different one. For example, this one. You can arbitrarily select, choose the one you need, which you want to see. Let's change the island solution type to the normal type, and again select the points we need to add using the preliminary search for contours. The highlighting of the area is now happening. Enter. We can preview and see how this object is being hatched. Enter. Let's open the hatching dialog box. Let's try the outer type. Again, we pick points. Enter. Confirm. And the hatching is performed in the following way. And the last island display style is ignore. Let's try to use it. Enter. That's how the islands work. Let's now try to set an angle, for example, 30 degrees and a scale of 75 and select. The hatching will look as follows. We can change the scale directly from the functional panel properties. We can either compress or stretch it without calling up the hatching parameters. Now let's use the parameter to create separate hatchings. Make sure it's checked. Add pick points. Confirm the actions. Enter. And then we can select each of the hatches separately. And it won't be a single entity but consists of individual objects. Let's open the Hatch dialog box. From this list, you can choose any brickwork pattern. I will use this one. OK, next, click the specified origin. Mine will be in the lower left corner. Next, we will add a boundary for further hatching. OK. And we can see that the construction of a solid brick starts from this angle. We can change the hatch scale. Let's make it 100. So, with the selection of the base point, this hatch will align itself to the selected point. Next, we have associativity. Let's try turning it off. And apply one hatch with associativity enabled on one, and on the other, we'll turn it off. Now, after changing the hatch boundaries, the hatch pattern itself remains unchanged. But if we hatch the second rectangle now, with associativity enabled, then after changing the contour boundaries, the hatch will adjust to it. Now, let's consider the gap tolerance. Also, create a rectangle and break it. Then, break it at one of the points. For clarity, let's use the inquiry utility and measure this gap beforehand. Now, go to the hatch. For the gap tolerance, let's make it more than a gap. Now, pick points. The program immediately signals that there is a gap in this corner, but nonetheless, the hatch will be executed. Let's click inside the contour. Confirm the actions and finish the hatch. In this case, this gap will be ignored because we've specified a gap tolerance. Maximum gap tolerance more than gap. This is how hatch parameters are set up. Also, let's briefly look at gradient filling. The dialog box is slightly different from hatching. Here, we can adjust the color in which we want to fill. Swap it. Choose the gradient type. And also specify the orientation with an angle. Let's use the curve parameters. Pick points. Confirm. This gradient will look like this. And basically, that's it. All files that store hatches are located in files with the extension .shx. And they are stored in the following directory: /programdata/nanosoft/as/nanoCAD. The shx folder. Here, you can find standard hatches. And after creating your own hatch in nanoCAD, you can upload it to this folder, and it will be automatically recognized in the hatch parameters.